That's what we're going to do is look at the polar form of a line. It turns out that they can all be written in a common way, which is why we care about this. So as you can see in the figure here, we have a line that has a perpendicular line. That's the one with the length r sub 0 that links up to the origin. So go to the origin to the line, and the distance that creates a perpendicular is r0. And then any old point on the line will have a distance of r, so that's denoted by the point r theta, which is right here. So notice that the angle that it makes, or the angle between the two is theta minus theta 0, this angle that's highlighted right here. Notice there we have a right triangle that involves everything we need. So it looks to be like if I just focus, like I said, on this triangle, it looks like that I can write, now I don't care about this side, but I do care about the r0 because that's given in the problem essentially, and that this is the length of r. So I'm going to say that cosine of theta minus theta 0 is equal to the adjacent side, which is r0 over r, which is the hypotenuse. Now, we don't like to normally leave equations like this in fractional form, so I'm going to write r cosine of theta minus theta 0 equals r0. And that's going to be the equation of our line in polar form. So when it meets these requirements, this is what we're dealing with. So looking at the first example, so let's say in this scenario we have r0 equals 6 and theta 0 equals pi over 3. So we're talking about an angle of pi over 3 with the axis, which means that my line is going something like this, okay? And that this distance is 6. So the equation of that line, according to our formula, is r cosine of theta minus pi over 3 equals 6. So we wrote it in polar form. That's good there. Now what we're going to do, so I'm going to write polar here. Now what we're going to do is try to get it to rectangular form. Now before we do that, I'm actually going to perform this operation here, which remember is accomplished by using a trig identity. It's a difference of angles identity, so it's r times, now remember how cosine of difference goes. It's cosine first, cosine second, plus sine first, sine second. And then I'm going to multiply the r through. So we have r cosine theta, and cosine of pi over 3 is 1/2. We have r sine theta, and sine of pi over 3 is root 3 over 2, and that all equals 6. Well, gee, if the goal is to go to rectangular, now look at this. R cosine theta and r sine theta have beautiful substitutions for polar coordinates. This is x, 1/2 x, plus root 3 over 2 y equals 6. You can write this any way you want to. I might write it this way just to get rid of the fractions. And there's your equation in rectangular form as well. So there's your relationship between lines and polar coordinates. Coming up next, conic sections. Thanks for watching.